Welcome to qnawire.
We'll be looking at introduction to thermodynamics for this particular problem, this ranking cycle. We want to determine the net work, specific network. We want to determine the heat transfer to the working fluid as it passes through the boiler, and we want to also determine the thermal efficiency and the rate of heat transfer. Okay, from the working fluid through the condenser, right? So if you have this as okay, if you assume that the turbine is exiting at saturation point, okay, and this pump is this the pump is has a saturation efficiency of 0.75. If you call here point 1, here point 2 for the actual cycle, you can call this the exit of the pump 2A, okay, and here is point 3. Sorry, let's call here point 2, point 2 prime, right? Here point 3, okay, here point 3 prime, the entrance of to the turbine, and let's call here point 4, okay, and for the actual cycle, let's call here point 4 prime, this temperature, degrees Celsius, this entropy, kilojoule per kilogram per Kelvin. We apply the governing relations equation for solving problems in involving ranking cycles, right? So we can just look for, we know that here we have been given that here is a 160 bar, 16 megapascal, and the temperature there is 520 degrees Celsius, okay? And this other point, which is at the end exit of the condenser, we have 0.04 bar, okay? Look for H1, check on your table, you're going to give us steam table 121.46 kilojoule per kilogram. All right, you can also look for the specific volume at that point. It's going to give us 1.0004 times 10 to the power of minus 3 cubic meter per kilogram. The pressure here is 0. 0. Sorry, I just mentioned pressure already there. Then we have at this point at point 4, sorry, at point 4, we have this point at point 4 here, H4. We're having it as 2561, 256, the enthalpy 2561.7 kilojoule per kilogram, right? So we've gotten a lot of information, okay, and the pressure here across the pump there, up there from here, is at this point is 0.16.162 bar. All right. So if we apply all this information and get the pump work, that will give us point 1, specific volume at point 1, pressure at point 2. You already know 162 minus the pressure at point 1, 0.04 bar, 162 bar for point 2 P2. So if we sub plug that out, we are going to have 0.1626, okay, kilojoule per kilogram. We look for the actual, since centropic efficiency is 0.75 for the pump, 1626. So if we do that, 0.75 and 75%, you arrive at, divided by that, you arrive at 0.22, okay, 22 kilojoule per kilogram. All right, you can just look for what H 2A will give us, 2 substitute A, H 2 substitute A, the enthalpy there, to give us the enthalpy at 1, which you already know, point 1 plus our 0.22, which will give us equal to 1.121.68 kilojoule per kilogram. You can go ahead and look for the turbine work. It's going to give us H at 3 prime minus H at 4. We plug in the values there, have it as 1.6 kilojoule per kilogram. You can actually also look for the actual turbine work, give you 991.6, okay, 991.6 times 0.8, which is the centropic efficiency of the turbine. To do that, you have the actual turbine work to be around 93.28. So that's what we are going to have for that. Okay. So we can also just look for what in advance. Let's look for what point 4 prime will give us. Okay. We know that H3 prime minus H at 4 prime is going to give us this value here now, 3.30 turbine work. So if we plug in the values, we can make this sorry for the formula, and we'll arrive at 2760.02 kilojoule per kilogram. So that's what we are going to have. So we can just go ahead and solve things now. For the A, the network, specific network, going to give us our turbine work, actual, minus pump actual. To do that, you have 793.06 kilojoule per kilogram. So that's that about that. Then you can come and do B, the heat rate of heat transfer. to the steam, working fluid passes through the boiler, and that will give us this. Let's say call it 3 prime uh, to 2A. So that's what that is going to give us, 2A. Okay. So if we do that, which is something that's saying H, this, W at this, enthalpy at 2A. Plug in the values which we've already got in there. We arrive at this to be 3, 4, 1.62 kilojoule per kilogram. Right, so you can come and look for the thermal efficiency. It should be equal to the work net, specific work net, and that our H3 is minus H2A. Since we are talking about specific terms, so this we can use this. So if you plug it values there, you get 0.23. Okay, then you can come and look for the which is rate of heat lost from the working fluid at the condenser end. We call this H4A. Uh, sorry, H4 prime. This prime we called it. Okay, that's what we look for the other time. Minus H at 1. So if you plug in all the values there now, H4 we already know, H4 prime we know it. I'm going to arrive to be 27, okay, 60 point 0.2 kilojoule per kilogram. So these are the